Okay, guys, good morning. We're back here in algebra. We're talking about ratios, rates, and conversions, okay? Ratios, rates, and conversions is very, very, very easy and very, very, very important. We have been learning about rates and ratios, believe it or not, since you were probably in 5th or 6th grade. You've been talking about ratios and rates, okay? And also conversions, you know, feet to inches, feet to miles, etc., etc. Those are all conversions, okay? So now, ratio. Oh, yes, sir. Okay, sorry about that interruption. So a ratio is a comparison of two numbers with the same unit by division. Now, when we're talking about the same unit, think about that, guys. It's the same unit. It's a comparison using the same unit. So what do I mean? In a classroom, there's a ratio of 10 boys to 17 girls. Aren't boys humans? Girls are humans? So same unit. Good. It was a ratio of 10 A's to 7 F's. They're both grades, right? Same units. Okay? So that's what I mean by ratios, comparison of two numbers with the same units. Same units, guys. All right? Same units. Now, there are 3 ways to write a ratio. Okay? You could say A to B. So, for example, we're going to use the boys to girls. You go 10 to 17. Or you could use a colon. 10 colon 17. That's still 10 to 17. Or you could put it in the most popular way. This is the way we're going to usually use it. Fraction form, 10 to 17. That is a ratio, same units. Now, a rate. A rate is a comparison of two numbers with different units by division. Okay? Different units by division. It's a comparison of two numbers with different units by division. So this is where we get into these examples. Like, I traveled 200 miles in 4 hours. Mr. Morrow graded 20 papers in 1.5 hours. The speed of a lizard that I saw crawling, he went 50 feet in 2 minutes. Do you guys notice how there's different units for each one? Different units. Different units, we're talking about a rate. Same units, we're talking about a ratio. Does that make sense?
Yes, sir.
Okay, now, yes, sir.
But how come they're considered the same unit one with ratios? How come boys and girls are considered?
The question was, how come boys and girls are considered the same unit? They're both human.
But
No, they're both human. Human is the same unit. They're humans. You have 10 human boys to 17 human girls. You had 10 grades that were A's, 7 grades that were F's. They're both talking about grades. But in the rate, miles and hours, there's no way that those are the same, my brother. Thank you for asking, sir. Now, unit rate. A unit rate is a rate with a denominator of 1. It's very simple. A unit rate is a rate with a denominator of 1. For example, what if I tell you, in the summer I traveled 500 miles in, let's say, 10 hours. Okay? I want to know my average speed. I want to know how fast was I going in 1 hour. I want to know the unit rate. So, what would this be? Guys, divide. 500 divided by 10. 50 miles per 1 hour. That's a unit rate because I have a denominator of 1. Does that make sense, guys? Okay. You sure? Okay. Awesome. Now, unit price. Unit price is also a unit rate, okay? Except we're talking about money. And the unit price is the price of 1 unit of a particular item. It's the price of 1 unit of a particular item. It is found by using the formula price divided by quantity. It is found by using the formula price divided by quantity. So, how does this work? I'm sure you have seen this all before. You go to the store and you see on sale, there's 3 cans for $10, let's say. Okay, you know you're going to pay $10 for all 3 cans, but me personally, I want to know how much am I paying for each can. I want to know the price for 1 unit of a particular item. So in this particular case, I'm going to find the unit price. And the unit price is found by going price, which is 10, divided by quantity, which is 3. Bless you. So I'm going to divide 3 into 10. Okay, goes in 3 times, which is 9. 1 decimal decimal. It's going to be 3.3 repeating, right? I can't put repeating as money. So how much, what would the unit price be here? $3.33. Whoever said 40 cents, I'm sorry, but you were wrong. It does not round up to 4, sir. Does that make sense? That is a unit price. Price divided by quantity. I want the denominator to be 1 because it is a unit rate. Unit rates are rates with a denominator of 1. Now, we're not going to do much investigation with proportions. We're going to learn about proportions separately either tomorrow or the next day. But what I want to show you and tell you is at least expose you to the definition of a proportion. A proportion basically are just equal ratios. They're the same value with different appearances. So for example, 2 to 3 equals 8 to 12. Sure it does. What's 2 times 4? What's 3 times 4? So didn't I multiply 2/3 by 4 over 4? What's the value of 4 over 4? 1. What's 1 times 2/3? 2/3, right? Hold on. I just said what's 1 times 2/3 and someone said 1. What's 1 times 2/3? 2/3. So when I multiply 4 over 4 to 2/3 and get 8/12, am I changing the value? I'm changing the appearance. Does that make sense, boys? Sir? Your question? Okay. You with me so far? Sure. Ratio, comparison of 2 numbers of the same units. A rate, comparison, it's a ratio with 2 different units. Unit rate, it's a rate with a denominator of 1. Unit price is found by price divided by quantity, where the denominator will be 1 as well. Next, conversions. Conversions, okay, are really important. Sometimes you have to convert from 1 unit of measurement to another unit of measurement. When you're doing conversions, remember the following, please. When going from a larger unit to a smaller unit, you multiply by the conversion factor. When going from a smaller unit to a larger unit, you divide by the conversion factor. I'm going to tell you what the conversion factors now in a second. What the conversion factors are now in a second. But when I'm going from large to small, I multiply. When I'm going from small to large, I divide. When I'm going from large to small, I multiply. When I'm going from small to large, I divide. When I'm going from large to small, I multiply. When I'm going from small to large, I divide. Now, this sounds all good, Mr. Morrow, but what is this? What do you do with this? Well, you have to know conversion factors to be able to apply this. These are the conversion factors we must memorize. Please listen to what I just said. You must memorize this. You must learn this. I will not give you a sheet for this. I will not let you write this down on a little index card. I will not put it on the tests. I will not put it on the quizzes. You must memorize this. You have been learning this since you were a kid. Yes, sir. This is not in your book. This is in my notes, in my PDF. That's why I always suggest that you print out my PDFs, sir. Thank you. So, let's talk about the measurements of length. There's 12 inches in a foot. There's 3 feet in a yard. 5,280 feet in a mile. And I'm going to give you 2 other popular ones. There's 36 inches in 1 yard. And there is, believe it or not, 1,760 yards in 1 mile. For weight, 16 ounces equals 1 pound. 2,000 pounds equals 1 ton. And capacity is basically volume. Okay, it's usually a liquid measure. And there are 3 teaspoons in 1 tablespoon. 16 tablespoons in 1 cup. 8 fluid ounces in 1 cup. 2 cups in 1 pint. 2 pints in 1 quart. And 4 quarts in 1 gallon. Now, these are the conversion factors, guys. Please remember, if I'm going from large to small, you multiply. Multiply. If you're going from small to large, divide. Now, let me explain this, because I know, I can see it in your faces, you're worried. I know that most teachers probably taught this in a very complex way. The way, bless you, the way I learned it, I never liked it. I hated it. I was always confused. So I figured out this little trick, and now my life is very easy with this. Let me give you an example. Let's say I've got 60 inches, and I want to convert it to feet. First thing you got to ask yourself, am I going from small to large or large to small? Small to large, because I'm going from inches to feet. So I'm going small to large. When I'm going small to large, do I multiply or divide by the conversion factor? Divide. What is the conversion factor of inches and feet? 12 inches in a foot. So I'm going to divide 60 by 12, and that's going to equal 5 feet. You're done. It's that easy. Let's go the other way. Let's say that I have, for example, 3 feet, and I want to turn it into inches. I'm going large to small or small to large? Large to small, because feet are larger than inches. When I go large to small, do I multiply or divide? Multiply by the conversion factor. What's the conversion factor with feet and inches? 12 inches in a foot. So 3 times 12 would equal 36 inches. Does that make sense, boys? Pretty easy, right? Be honest, it's a lot easier than what you probably learned. You guys probably learned how to do it with proportions, didn't you? If you learned it like this, kudos to your teacher. Good for them, because that's a great way to teach it. Does that make sense, everybody? Okay, now, I'm trying to be as thorough as I can. You must memorize all of this. You must memorize all of this. You must memorize all of this. So that means that on a test, you're not allowed to say to me, Mr. Morrow, I'm sorry, sir, how many feet in a mile? I cannot answer that. Are we clear? Thank you. Now, the metric system. The metric system is a lot easier than the English system, okay? I mean, a lot easier than the English system. The metric system, we're talking about kilo, hecto, deca, the units. Meter is represented by a lowercase m. Gram is represented by a lowercase g. And liter is represented by a capital L. Those are the units. Deci, centi, milli. A great way to remember this is King Henry died, unfortunately, drinking chocolate milk. King, K for king, K, kilo. Capital H, hecto. Capital D, deca. Unfortunately, the U is for basic units. Little d for deci. Little c for chocolate, centi. Little m for milk, milli. Please be aware that a little m by itself equals meter, and an m is millimeter. Please be aware of that difference. Now, how does this work? Oh God, it's so easy. Let me just show you by example and bless you. Let's say you have 32 hectometers and you want to turn that into centimeters. No conversion rates, okay? You don't have to worry about conversion rates here. Where are you starting here, guys? Hector under Henry, right? Hector. Where am I going, guys? To centi, right? Now check out this journey, please. 1, 2, 3, 4 places to the right. Where's the decimal of 32? Behind it. So I'm going to go 1, 2, 3, 4 to the right. Put my decimal. Fill in the zeros. And then the last step is make it pretty. 320,000 centimeters. By simply moving decimals, you're done. Does that make sense? Pretty easy, no? What if I tell you, excuse me, you have 0.425 centimeters, and you want to turn that into meters. Where am I starting? We'll do this in red. We're starting with centi, right? Where am I going? To meters. So I'm going 1, 2 to the left. So I take my number here and I go 1, 2 to the left, place my decimal, fill in my zeros, and then make it nice and neat. 0, 0, 4, 2, 5 meters. Does that make sense, gentlemen? You promise? Awesome. Just remember, King Henry died, unfortunately, drinking chocolate milk. And that will help you immensely. And then just remember, locate where you started. Move that decimal place to where you're going. That same movement you do to the actual number that you started with. Now, all of these directions are on this page. You don't have to write that down right now. In fact, you can just, like normal, print it out on the PDF. And if you're confused, you didn't understand how to do it, it's all written down here step by step. But in this particular case, I find that it's easier to go ahead and show you what you're doing instead of writing it out. Now, let's do some examples. Bless you. You're shopping for t-shirts. Which store offers the best deal? What do we have to find for each of these, guys? The unit price. Good job, son. So unit price, remember there's a formula for that. What's that formula, my brothers? Price over quantity. Thank you, son. So for store A, my unit price is going to be $25 divided by 2. So that's $12.50 for one shirt. Store B, $45 divided by 4. That's going to be $11.25 per one shirt. And store C, $30 divided by 3, price divided by quantity. That's $10 per one shirt. What's the better buy? What's the best deal? Store C. That's the power of unit price. That's the power of unit price. Does that make sense to everybody?
Yes,
Promise? Sure? Okay, because I see some people not doing anything. For those people, I just don't understand why you would do nothing. But, okay. It's your life. So let's continue then. Let's do some conversions. Convert each of the following. Okay. 330 minutes to hours. I didn't go over minutes and hours with you guys because I assumed that you knew it. Let's just make sure you know this. How many minutes in an hour? 60. How many seconds in a minute? 60. How many seconds in an hour? 3,600. Very good. How many days in a year? 365. No, we don't count the 1/4, but thank you. But yes, it's 365. How many months in a year? Good. How many weeks in a year? 52 weeks in a year. Very good. Okay. So, with that in mind, I'm going minutes to hours. Am I going large to small or small to large? Do I multiply or divide then? Okay, we're getting confused here. Some people said multiply, some people said divide. So I'm going to be nice. Large to small, you multiply. Small to large, you divide. So once again, my brothers, going minutes to hours is that small to large or large to small. So am I going to multiply or divide? I'm going to divide by 60 because that's the conversion factor. So I have a 60 here, cancel out my zeros. So this goes into 33.5. 5.5. So 5.5 hours. Or you could have written it as 5.5 hours. Either way. Yes, sir.
About 5 hours.
Okay, 5 hours and 30 minutes would be marked wrong because I did not ask for hours and minutes. I asked for hours. Thank you. Great question, sir. Now, 15 kilograms to grams. Whenever I have this situation, me personally, I go, okay, King, Henry, died, unit, drinking, chocolate, milk. Where am I starting here? Kilo, kilograms. Where am I going? I'm going to the unit. Very good. So I'm going 1, 2, 3 to the right. So I take 15 and I go 1, 2, 3 to the right. Place my decimal, fill in my zeros, and then make it pretty. 15,000 grams is my answer. Does that make sense, gentlemen? Okay, 11 pounds to ounces. Am I going large to small or small to large? Large to small. So when I go large to small, do I multiply or divide? Multiply. How many pounds in an ounce? How many ounces in a pound? So I go 16 times 11, which is going to be 176. 176. So 176 ounces. Okay, 5 feet 3 inches, but I want it all in inches. What would you do immediately to just not confuse yourself? Okay, these inches, bring them over here. So don't worry about those. You already know you have 3 inches, right? Now I got to go from 5 feet to inches. Feet to inches, is that large to small or small to large? When I go large to small, do I multiply or divide? What's the conversion factor between feet and inches? 12. So 12 times 5 is 60 inches. Plus the 3 inches, you got 63 inches. Does that make sense, gentlemen? Does that make sense, gentlemen? Okay. 1,250 centimeters to meters. Again, like clockwork. King, Henry, died, unit, drinking, chocolate, milk. Where am I starting? Centi. Where am I ending? Unit. So I'm going 1, 2 to the left. So I have 1,250 and I go 1, 2 to the left. I make it pretty. That's 12.5 meters. Is everyone with me so far? 6 hours and 45 minutes. I want it in pure hours. What's the first thing you think you should do?
40 hours.
Yes, these 6 hours, you already hours. So you already have 6 hours. Now, I have 45 minutes. I'm going from minutes to hours. Am I going large to small or small to large? When I go small to large, do I multiply or divide? So I go 45 divided by 60, which is the conversion factor. I can divide 15 to both top and bottom, and you're going to get 3/4. So, plus 3/4 of an hour, this would be 6 3/4 hours, or 6.75 hours. Fraction or decimal, either way. Does that make sense, gentlemen? Now, I would never call out names, but if I would, there'd be a lot of people embarrassed right now on my video, because I have a lot of people just sitting there playing with their pencils. I just want to say it's a little sad that a lot of people are working hard, and I'm working hard, and some people are just, fiddling with their pencil. I don't understand how their pencil fiddling is going to help them do the math, but okay. All right, next. The CN Tower in Toronto, Canada is about 1,815 feet tall. About how many meters tall is the tower? Use the fact that 1 meter is about 3.28 feet. First things first, I'm going from 1815 feet. I want to know how many meters it is. So first things first, am I going large to small or small to large? Small to large, guys. Remember, if 1 meter is about 3.28 feet, that means that a meter is larger than 1 foot, right? So I'm going from small to large. When I go from small to large, do I multiply or divide? I divide. So I'm going to take 1815 and I'm going to divide it by 3.28. Okay? And I'm going to cheat because I already have a degree and I can. And I'm going to use a calculator for time's sake. So you would divide 1815 divided by 3.28. The setup would be 3.28 on the outside, 1815 on the inside, 1, 2 to the right, 1, 2 to the right. Okay, and then you can go from there. The answer is going to be 553.35, and it keeps going, but we stop at the hundreds. So that's going to be 553.35 meters. You have my word that if you see something like this and it's crazy math, you can use a calculator. But I'm going to make sure that all the math can be done by hand. Okay? Yes, sir. If the conversion between metric and linear, they have to give you the fact. See how they gave you the fact ratio, the conversion there? They have to. For example, 2.54 inches equals 1 centimeter. Nobody knows that. I know that because I'm a math teacher. But if I'm going to go from metric to English, I have to give you that conversion, sir. Okay? Thank you, my brother. Does that make sense, guys? Okay, now, the piece de resistance. This is the good one. I'm not going to worry about the math so much. I'm going to do a lot of the math on the calculator. What I'm going to worry about is the procedure here, okay, guys? So please just follow directions and pay attention. A student ran 50-yard dash in 5.8 seconds. What is the speed? At what speed did the student run in miles per hour? So think about this. This is a double conversion. Got 50 yards in 5.8 seconds. I want to turn that into miles per hour. Are you with me so far? Okay. Let's do one conversion at a time, okay? Please. First, let's convert the 50 yards. I'm going yards to miles, right? Is that small to large or large to small? Small to large, right? When I go small to large, do I divide or multiply? Divide. So check this out. I'm going to go 50 yards divided by 1,760. You with me so far? So 50 divided by 1,760 will equal, bless you, 0.28409,091. It's a real nasty number. So I'm doing it in a calculator. Please hold all your questions till I'm done. 50 yards divided by 1,760 equals 0.028409091 miles. Okay? Yes. If this were a test, you can round to the hundreds. Yes, but I want to show you exactly what's going on here. Now, we're going to divide that by the second conversion. Our second conversion is 5.8 seconds to hours. I'm going from seconds to hours. Am I going large to small or small to large? Small to large. So do I multiply or divide? What am I going to divide by? It's not 60, guys. There's not 60 seconds in an hour. There's 3,600 seconds in 1 hour, guys. There's not 60 minutes, no, because it's seconds to hours. Remember, we went over the time one, and we went over this. So now you got to go 5.8 divided by 3,600 equals 0.00161111. Now, at the end, and that's hours. Now, that's a rate. How do I get that rate to become a unit rate? How do I get that rate to become a unit rate? How do I get the denominator to become 1? I divide. Thank you. Guys, didn't we just do that? If I had 240 miles in 6 hours, didn't I say to get the unit rate you divide, and that's 40 miles per 1 hour? And what's the problem? It's the same thing. Oh, but there's ugly numbers, Mr. Morrow. So what? Who cares? So what? Is this a rate? Yes or no? How do I make a rate a unit rate? Divide. Period. Does it matter how ugly the numbers are, guys? No. Now, I'm going to use a calculator. And I'm going to go ahead and divide. Divided by 0.0016111. So that's going to equal 17.63 miles per 1 hour. And that's that. It's that easy. Now, these numbers were ugly, but the procedures should have been easy. Now, you had a question. Okay. Now, let's show you something that's a little bit easier, so you know that it's not going to be all crazy like this. What if I told you I went 3 miles per hour, and I want to turn that into feet per second, okay? First things first, I got to go 3 miles to feet. Miles to feet, is that large to small or small to large? So when I go large to small, do I multiply or divide? Okay, so first one, 3 miles to feet. You're talking about 5,280 times 3, 0, 4, 2, 8, 15. So that's 15,840 feet. So I got 15,840 feet. Done with that conversion. Next conversion, hours to seconds. Okay, we already know that. Am I going to multiply or divide? Because I'm going large to small. Okay, what's the conversion factor? 3,600 times 1 is 3,600 seconds. So I got now 3,600 seconds. Cancel out the 0, and now you divide, because I got to find a unit rate. 360 into 1584. I've only got 1 minute, so that's why I'm not going to do it out. But you have to do this one out. 1584 divided by 360 equals 4.4. So it's 4.4 feet per 1 second. And that is how you convert. May God bless you all, and have a wonderful day. Thank you for a good lecture.